Okay, we'll get started. Thanks everyone for joining this session. The question that we're hoping to answer today is how can AI streamline WCAG compliance? So ideally, by the time you leave, you'll have a clear answer to go build your own version of Test Party yourself. That's what essentially the goal of this session is. I always like to start with stories because I feel like those are always the most memorable and impactful parts of these types of talks. And the story that I love is when I was growing up, I watched a lot of Saturday morning cartoons. And my favorite cartoon of all time was Teen Titans. I'm sure a lot of you have seen Teen Titans, but if you haven't, it's this TV show with 5 superheroes who are all teenagers that fight crime around the world. So from left to right, there's this on screen here, there's Raven, who can like shoot like discs from her hand. It's like alien life form. There's Robin, who eventually became like, Batman's sidekick. We all know Robin, but this was Robin in the early days. There's Starfire, who is another alien that shoots different color beams from her hands. There's Cyborg, who, was this half cybernetic, half man. And there's Beast Boy, who could like transform into any animal, I guess, possible. Or I guess not even animal. He turned into dinosaurs too. So I guess animal and dinosaur and insect. I guess he could just transform generally. But of these 5, my favorite was Cyborg for 2 main reasons. First, he was, this half cybernetic, half man, chief technology expert, right? This guy who could shoot blue beams from his arms and could teleport and could create portals. But second, because he reminded me of me, right? He was a Black superhero who loved technology. And it wasn't until I was reflecting on making this talk that I realized he was also a disabled superhero. Actually, probably the first time I saw a disabled superhero on TV, right? And I dug into the story of Cyborg, or Victor, as he's known, before he had his accident. And Victor Stone, his story is that he was this strong teenager who was like the football star and the football quarterback until he had an accident that ended up killing his mother and injured him to the point where his father, this experimental researcher, decided to use cybernetics to save him, right? And that's how he kind of became this new person who wasn't Victor Stone, but was instead Cyborg. So why am I telling you this? Well, I think there's a lot to learn from Cyborg as a superhero because he had all of these assistive devices that allowed him to do more in the world. And I hope that by the end of this talk, you'll come to the realization that with assistive devices, you as accessibility experts can also do more in the world. Really, the formula that we're going to look at here is this one here. Obviously, I wasn't a math major. I studied philosophy. So this is this is as mathy as my math gets, which is this equation that Victor Stone plus technology plus heart equals a superhero, or in this case, Cyborg. And for you, I hope to convince you that you plus AI tools plus heart can make an accessibility superhero. So I'll start by just describing a bit more of my background and where I came from. So who am I? And why do I have any authority to talk on this? Well, here's me back in my Teen Titan watching days. I'm on the left. That's my brother on the right. He actually just graduated from med school last week, and so we went out to Spokane, Washington, and my mom said to me, "When are you going to become a doctor?" Okay, Mom. Thank you. Growing up as a kid of Ghanaian immigrants, it was always like doctor, lawyer, or engineer. I don't know anyone else. Maybe it's heard that trope. I kind of went engineer a little bit. I worked at Microsoft, and then I decided to go into business, and it just broke my mother's heart. So on Mother's Day, I called her, and maybe this wasn't the best thing to do, but I said, I think I'm going to shut down my business and go to med school. And she said, no. So it's fun. But this is us circa 2004 in Seattle, probably at like a Chuck E. Cheese or something, playing some like arcade game. And growing up, I was always super nerdy. I loved computer science. I took an AP computer science class when I was in high school, and it was actually one of my most impactful classes. And it's the reason I study CS today. And there were Microsoft employees who would come from Microsoft to my high school to teach us. And it was back in like, I might age myself, or I guess young myself in this case. But it was in like 2013, right? Sophomore year, and these Microsoft employees would come and teach us all about computer science and how to build technology. And that, you'll see this a lot at this conference, especially. That's why we sponsor students to come to these sort of conferences, because you never know what kind of ripple effect that'll make. But I kind of became a superhero, like growing up in school. Realized that I couldn't see the board. That was why I was getting bad grades. Did some eye appointments that were like, funded by the school in Washington. They mandate that students go do eye appointments, near appointments, and I realized that I had some troubles there. And that's how I kind of became a superhero myself. And here's like my cyborg blue watch as well to go along with that. So who am I now? I'm the founder and CEO of a company called Test Party. Our focus is all around automated remediation, which we talk a lot about automated testing, which is amazing. I think there's some great companies doing that in the space. Axe Core is an example. Evinced has great tools. DQ has great tools for what I'll call automated testing. Our question as a business is, what do you do once you get that 100-page report, whether it's in a PDF or in a pretty dashboard? So we're all around automating remediation, starting with the WCAG rule set and then building into our own rule sets, which in our next talk, Jason will talk about the mobile rules that we're building, the 20 that we're building, based off some of the open source rules that we've seen from CBS and T-Mobile and BBC. And that's really our focus as a business. Obviously, I'll preface this by saying, like, automation can't solve 100%. Or maybe it can. I guess that's the purpose of the talk today, is to ask that question. Before that, I studied computer science and philosophy at Harvard. It was a really interesting place to do that because it was in the 2016 to 2019 range. And so everyone in my department, there was 30 philosophy majors, and there were 3 of us who did philosophy CS. We were all looking at privacy and social media. It was right around the time that Cambridge Analytica was a huge deal, that Mark Zuckerberg and Facebook and people realized just how powerful advertising could be to influence elections and really just any type of behavior. And it led to this question of, well, what does privacy mean online? And the result of that was GDPR, right? Which obviously in Europe now is the reason why you see these cookie banners on websites. It's the reason why there's privacy regulation that goes global, because the internet has no boundaries. So whatever happens in Europe tends to spill over to the US. And I'm speaking to an audience here that understands that, especially with accessibility and the European Accessibility Act. That's why at least I'm hoping that come July, there will be the same spillover effects for accessibility that there were for privacy. But that's my background. And then outside of that, I first got into accessibility by working at Google, hoping to make some of their accessibility design checklists back in like 2016, 2017, and then spent some time at the UN in 2022, 2023, making sure their online resources were accessible. So that's who I am now. And yeah, I'm still very nerdy, so you can tell. And so who I am with Test Party, I tend to think of myself as becoming cyborg, right? And really the purpose of this talk is to talk through how we bring cyborg principles into our work, how I think you can bring cyborg principles into your work, and some of the really easy examples, whether you're using a Test Party or some other AI tool, that you can start to augment your own abilities to do more. And really the thesis of this presentation is that by automating WCAG remediation, you can use AI as an assistive technology to become a digital accessibility superhero who can do more in the world. So here's the short agenda for today. We'll talk about where we are today in terms of what technology can do today with AI. We'll talk about where we are in terms of an industry. Where is digital accessibility? Then I'll try to come up with 3 really practical AI WCAG remediation techniques. We'll talk about the impact of this, and then we'll end with Q&A. What time am I supposed to end at, so I can make sure at 10? Is that the plan? 10 o'clock? Okay, cool. So I'll try to leave at least like 20 minutes for questions at the end, so that we can just have a discussion, maybe even 30 minutes. Like, I think that's what's unique about Access U is they have these longer sessions, so we can kind of go back and forth and have discussions. And what I've done in the past after this presentation is some of the questions are specific to how would we solve XYZ issue, and we can pull up our own system or even a ChatGPT or a Claude and see how some of these tools handle it in real time. So that'll be the last, call it, half hour, since I don't really want to be lecturing. I would usually fall asleep. So I don't want to put any of you to sleep, especially the Zoom folks. I can't see you all, so I'm just assuming the eyes are already closed, just for my own sake and sanity. Cool. So any questions before we dive in to any of this? Perfect. So where are we today? the internet is inaccessible. 95% of the internet's homepages, when scanned with WCAG, fail, right? This is the Web A Million study. I think a lot of us know about this study. They do it every year, and the number usually changes between 95% is inaccessible and 100% is inaccessible, which is the number that we all recognize. In addition to that, the web is becoming even more complex. As of this last study, 12%, there was a 12% increase in the average number of elements on a homepage, meaning that if you're going and testing a website, you have to do 12% more work this year than you did last year. And probably the same is true for next year and the year after and the year after. Our belief is that manual audits are quite slow, right? Meaning that it takes months to actually complete an audit, to get the results, to send it back to a client. And hopefully then that client takes the results, sometimes they do, sometimes they don't, to fix it, and then you have to get audited again, right? And that process is just lengthy, right? So there's two barriers to this. Obviously, there's 95% of the internet that's not accessible, and if we're not able to do this work faster, we won't be able to actually audit those sites to give them feedback on how they could be more accessible, right? So there's this downstream effect of what happens when audits are slow. And inaccessibility is expensive. If you don't comply, you're likely to get sued, right? We do a lot of research ourselves to try to figure out how much is being paid out in lawsuits, and our estimate is about $1/3 billion in the last 5 years have been paid out in settlements and fines and fees. A lot of these settlements are private. They happen behind closed doors. This is US. This is just US. Yeah. Yeah. There's less litigation outside of the US than there is in the US. But yeah, what we find is that a lot of these settlements are private, right? And so people don't want people to know when they've been sued and when they've settled, to keep down the brand risk and the reputational risk and the economic risk, which makes sense. Even customers that we work with, who we work with in the midst of a lawsuit when we publish a case study, don't want any mention of being sued or settling or anything because they don't want to be retargeted, which is kind of an unfortunate truth in the industry. And I think all of you in this room are going to resonate with this fact. It's the fact that accessibility employees have burnout, I think, at higher rates than other professions. There was a survey done by Devin Persing that showed that 61% of accessibility employees don't feel like they have the resources or support to do their accessibility work effectively, right? And so what can we be doing to give everyone in this room, everyone on the Zoom, and the people that you're influencing the tools so that you don't burn out, right? And I think the reason for this burnout is pretty clear, and it comes back to something that I learned from Cyborg in season 2, episode 4 of Teen Titans, where he said, "When I was an athlete, when I was human, I loved pushing my limits." I think that sounds a lot, very familiar to everyone in this room. Getting stronger, faster, better, just by training harder than I ever had before. My coaches would always tell me to give 110%, and I always did. And I think in this room, we're giving 110%, but we're only getting 5%, right? We're giving that all of our effort, these audits, which take time, right? We're getting burnt out. We're trying to influence change, and yet only 5% of the internet is accessible. And so there's a question, like, what can we be doing to give 110% and maybe get 10% or 20% or 30%? And it comes back, I think, again, to this philosophy math equation, right? In this case, Victor Stone had some technology that augmented him to do more, to avoid this burnout. And this assistive technology, I'm questioning, maybe that's AI. Like, is there a technology that we can use as professionals to augment our own abilities? And so let's start by just talking about how much we think can be automated. So I'm going to do a quick poll and ask this question of, how much of the WCAG do you think AI can automatically remediate? Yeah, today. Maybe we'll do like a show of hands. I see some things coming in the chat, but who thinks it can automate 100% of the WCAG? Okay, no one. Maybe 90% by show of hands. And in the chat, you can type your answers. 90%. Keep your hand up. Who thinks like 50%? Like at least half can be solved. Okay, I see some good. And we're talking remediation, not just testing. Okay, who thinks 20%?
So you mean fixing as well?
Yes, finding and fixing. 20%. Okay, who thinks it's impossible? 0%. Okay, so we have no skeptics in the room, which is great. On Zoom, I see a lot of 50%, 25%, 40%. I would say about 70% of the room, their hand came up at about 50% or higher. So we'll see, right? Let's start first by zooming out and defining what I mean when I say AI, right? There's a lot of speak about artificial intelligence, and I think there's lots of different types of artificial intelligence. So I want to be really clear about what type of artificial intelligence I mean. When I say AI, I mean the large language models that are kind of, we've all seen them. You prompt and it gives some results. And I'll just quickly dive into what these large language models are doing really at a high level, is that they're trained on a lot of data where they're trained to recognize patterns, right? So I might say the cat and the hat, right? Right. Or we might say, my favorite animal is a dog, right? Obviously, dogs are better than cats. Large language model here. It's proven by AI, so it's true. But it's these large language models that are just really prediction engines. And what's been interesting in the last 3 years is that these prediction engines have gotten better and better at predicting within larger contexts, right? In like 2016, 2017, the research, you could really only predict maybe one line or one sentence at a time. Now we can predict whole, books, right? I can go and prompt it and say, what is 10 things I should remember from my accessibility program? It'll give me a very detailed 400, 500, 600 word response. And so that's what's interesting about these models. And the way that that comes about is really through something called embeddings, right? And so when let's say I feed a book into a large language model, the way that this works is it takes that book, and if I have, say, the sentence, the cat and the hat, it'll turn that sentence into numbers, right? So it might be 13, 15, 17, 12, right? And then if I say, where is the cat? That question will also be queried into numbers, maybe 7, 15, 13, 12, 11. And what the model is doing is essentially comparing the numbers to each other and saying, okay, every time I see 12, hat, and the phrase in the, which might be 13 and 5 or whatever, I know that cat tends to follow. And that's essentially what these models are doing at a large scale, right? And so you can take this book and you can embed it, then you can embed the embeddings, then you can embed the embeddings, and you can make this really compressed and small to the point where you ask a question and it's able to get an answer at a much larger scale. What's interesting about this large language model technology and what's called transformers is that you can now embed not just words into numbers, but you can take an image and embed pixels. You can take songs and embed maybe the wavelengths, right? You can take, a video and embed every part of that video from audio to image to captions at the same time. And now that you have these really detailed embeddings, you can start to ask questions to really weird forms of technology, right? So when you look at the image generation models, that's really how they're working, is that they've embedded this image in the same way that you would embed a book or a sentence, and they're really starting to get out these interesting results. So within this kind of framework, there's two types of models. There's what's called the reasoning models, where you ask it a question, and it starts to reason how it would solve the answer, and then go through the steps. And there's the frontier models, which are based on just trying to get more and more and more data, and based off more data, asking it better questions, right? And so if you look at what the frontier models are, the ones that just have really large data sets, it kind of reasons that they come from large companies, right? Gemini, which is Google, GPT, which is OpenAI, they have like $18 billion in funding. Llama, which is from Meta, DeepSeek, which is like the Chinese competitor that popped up, Claude and Grok, right? All the people behind these models have a ton of money to just either buy data or tag data or create their own data, right? And so in this game, at least of the frontier models, the people who win are the ones that have a lot of data. So when I say large language models, that's really what I'm thinking of and talking about. There is a lot more research being done on reasoning models. Like, can you take a smaller model and just have it ask itself questions to reason to better solutions, right? And that's we won't talk about that in this talk. I'm just going to focus on the large language models. But I do think that, like, when you think of AI agents, they're really just reasoning models, right? They're doing a lot of this kind of frontier model work, but also adding some logic on top. So that sort of stuff I'm not talking about in this presentation, but I do think that the future of a lot of automation will come through that reasoning. So here's how these large language models, the ones that just have massive data sets, perform. And what you're seeing on the screen is a bunch of standardized tests that some of which I had to take in the last decade. some of which I would never take, like the LSAT. And this is the model performance across the board. Typically, you could say a passing rate is about 80%. So if you can take this test and pass at 80%, you're said to be pretty proficient in this industry. So in this case, you can look and see we have Claude 3.5 that took the LSAT and got an 80%. It took the SAT reading and math and got above 80%. You can see some other models like GPT-4o did really good on the GMAT verbal and the AP calculus exam. And there's some other stuff here. And then there's combined models. Maybe if we ask the question to every model and take all the results, what is it going to be? And it seems like AP World History is 100%. And so there's a question of what does this mean when AI is able to pass really complex standardized tests that before used to be barriers to get into certain professions, right? Before I couldn't even take the LSAT, or I couldn't even become a lawyer unless I took and passed the LSAT. And now we have an AI model who's able to do that, right? There's also similar research that's not on this slide about medical models, right? Medical models that can diagnose patients at a higher accuracy and frequency than humans can, right? And so when this is happening, what do we do here? You'll notice as well that every model performs differently, right? And so this study just looked at the best performing models in each of these industries. And you can see that GPT-5 or Claude 3.5 and GPT-4o is better at certain things and Llama is better at other things. Of course, there's now like even more advanced models than the ones here. So this is what I mean when I say AI, right? Just taking a bunch of data, asking a question, whether it's a test or something else, and getting the result and evaluating it. I want to dive into a research study that I conducted with some colleagues 2 years ago when I was at Harvard Business School. And this was in September 2023, probably about a year after ChatGPT had come out. The study was pretty interesting. What we did is we looked at 8% of BCG's global workforce, which is about 800 consultants, and we had them do 18 real-world tasks, from creative to analytical to persuasive. Specifically, the task was, I want you to design a new shoe campaign for Nike. And we had 18 questions that they had to do to finish that campaign. We gave half of the group GPT-4 access, and half just had to do the 18 tasks, as if they were a consultant hired on the case. We gave no training, no fine-tuning. It was just off the shelf. The results were pretty interesting. We noticed that the people who had AI were able to do work about 13% faster. They did about 13% more work. They did it about 25% faster. And the output, when rated by evaluators, was 40% higher, meaning that they had more quality outputs. What you see on the screen here is just a quality rating from 1 to 8. Then you see those who didn't use AI had an average of a 4 quality rating, and those who did had an average of a 6. Right? And some of these questions were like, create 10 creative names for this new marketing campaign, or find a new target audience for who this campaign would go to. And we just found that the AI ended up doing significantly better. Yeah. Yeah, there's a mic coming. And feel free, if you have questions, just raise your hand. I'll pause at any point.
Sorry, no really.
Or in the chat.
Just want the density. What is that density? Maybe you covered that. What does that mean? The density, that higher density on that did not use AI versus used AI.
Yeah, so this was like the number of respondents. So like we split it up into half, right? And so you'll see that that's why there's like half are blue and half are green and red. Yeah, but you mean like the vertical axis? Yeah, it's just like number of responses, like number of people who we saw get a 4.
Oh,
number of people who we saw get a 6. Yeah. That's what that translates into. Yeah, of course. What you'll notice is that within the used AI bucket, right? Because everything here, the green and the red, both used AI. There's also a slight deviation, right? There's those who used AI and scored a 5.8, and those who used AI and scored about a 5.9. And so it seems to imply that there are certain ways of using AI that's better than other ways. And really, the results, when we dove into it, was that we found that within those who used AI, one set of consultants acted as centaurs, like the mythical half-human, half-horse creatures. And they really just divided and delegated their solution-creating activities to the AI or to themselves. So what this means is like they used AI like a calculator, right? Like when I came to a problem, maybe it was 2 plus 2, I would just type into the AI, what's 2 plus 2? And it would spit back 4, and I would just take the answer as is, right? Versus there was another set of consultants that acted more like cyborgs, completely integrating their task flow with the AI and continually interacting with the technology. So what that meant is, using the calculator example, it's almost as if I had a calculator and I said, what's 2 plus 2? And it spat back 4. and I said, walk me through how you got to 4. And it gave me how it walked through to 4. And I said, actually, I see the way that you're doing this is a little bit strange. Maybe try it this way. And then taking that result or that response instead, right? 2 + 2 is 4 is a binary answer. So it's a bit, maybe it's not the right example, but you can see why interacting with the AI more tends to lead to better results. And we found that the cyborgs, the people who prompted on average 3 or 4 times for every question, had better results than the centaurs, the people who just prompted once and copied and pasted whatever came out first. We also saw that when you looked at the results, there was the biggest improvement for the lowest performing consultants. So, it's BCG, they evaluate people all the time, and we took a random sample of 8% of the staff, and we knew what their performance was before they came to us, right, as a researcher, as a research team. And we saw that those that performed the worst in their general jobs had the biggest improvement. And those who were already good, improved a little bit less. Right? For us in this room, I think what that'll mean is if you're already an accessibility expert, AI probably is not going to help you that much. Right? Like maybe it'll help you when you're already tired and you're not really sure what the solution is and you want to double check. But if you give it to someone who has no idea about accessibility, it'll help them become more expert level than an expert who already is really good. Right? That's what this study result is kind of implying. And really, we saw that the bottom performing consultants improved about 43%. For context, there's estimates that when steam and power entered factories in the 1800s, that improved performance by about 18 to 22%. Right? So the performance gains by AI is pretty significant, but because it's in the knowledge workspace, it's kind of hard to quantify. Like we're not just generating more cars, right? Which is what happened in the, probably not cars, buggies in the 1800s, right? We're not just generating more things, but we're able to do more, right? And sometimes that's invisible because of just the nature of how AI works. So here are the 2 takeaways from this first study. One is that an expert AI is better than the average human, right? That was the study about the LSAT that I showed, the SAT math, the GRE. But that an expert human is better than average AI, right? Like I said, these large language models are just taking massive data sets and you dump a bunch of data into it, and it's going to get like an average response. And that if you're an expert in this topic, you're going to be like, this average response is pretty bad, right? And so that's what we say. We say frontier AI models can turn an average individual into an almost expert in any field, but experts in specific fields still beat AI. The second takeaway from this study is that how you use AI matters more than just using AI. So if you use AI as a cyborg, prompting it multiple times, you're going to have better results than if you use it as a centaur, just asking it one-off questions. And what this means is that you should integrate AI into your human tasks versus separating tasks. So I'll pause. This is like the first big, hopefully like mind-blowing mic drop moment of the talk. So I want to pause and see what questions people have about this study. Yeah. And those on Zoom, feel free to add thoughts in the chat.
Expert. To me, it's more like it'll produce expert results, but not really turn that person using the AI into an expert.
Yeah, that's fair. That's fair. We could separate out the results of an AI versus like, are you actually learning from this AI system?
I've seen some good work if you really train them by rote.
Yep.
But they really don't get the concept behind accessibility. So I kind of
Yep.
feel like that same idea is like,
Yep.
we can get better results.
Yep.
But the person doing the work, I would not call them an expert in that sense.
Yeah, I guess it goes back into like if you just look at the results of someone's work and don't look at their process and you just judge the results, could you call them an expert or not? And I think that the process matters. And so like you have to have an expert process to be an expert. But in a world where sometimes results are all that matter, expert results are enough to be said that, it's good enough. But you're right. AI training or training is different than results. Yeah.
Hi. Question. I'm just a little puzzled about one thing, which is in your study, how do you know that it isn't did you randomly assign who got to use AI and who didn't?
Yeah, the AI usage was randomly assigned, and it was of that group of 800, half got AI, half didn't.
I'm just wondering if the more high-performing consultants will tend to be more adventurous about using new things. AI or whatever.
Yeah, in the context, I think also, I'm not sure if the mic is on. Someone said to rephrase questions. So I'll rephrase the question. The question was twofold. They said, one, was it randomized? And two, it seems like the higher performing consultants might just want to play around with this technology and be better at it. And I think that's true. I think the experts still had a gain, but it was a lesser gain versus the people who don't naturally play around with these tools had a bigger gain, like the amateurs. So I think that would be my response to that. Yeah.
Hey, how's it going?
Good.
So I'm, just kind of going in my head, so I had to. But, so expert human, couldn't it also be like expert human equals expert AI? Because if you're expert in your field, like AI is kind of what we make it, when we
Yep.
input and ask the question. So they would ask more expert like level questions.
Yep.
Which means the AI would give you more expert answers.
Yeah.
So, I mean, I definitely, expert AI over average human, but in the same sentence, kind of, is it expert human equals expert AI and average human equals average AI?
Yeah, because I think especially, so the question was, can we add another line here that says expert human equals expert AI? And I think because of these large language models, because they just rely on questions, like you have to ask good questions to get good answers, right? If you don't ask great questions, you don't get super great answers. So even one thing that I do a lot when I'm prompting, when I'm not an expert, is I'll say, this is a problem I want to solve. What questions would you ask an LLM? And I ask my LLM. If I wanted to solve it, then it would give me the questions, which I then paste into another chat to then ask the questions that I didn't know how to ask, right? And so sometimes finding the right question is more important than having the answer. But that's why I think experts with AI tend to perform better than average people with AI. Yeah. Hey.
So I understand that part of the first portion of this talk is to establish that LLMs in particular are good or quality or bring value. And I get all of that. You're setting up that first part of the argument. But some of the initial stuff you say, you talk about standardized tests, and those are a much richer and deeper corpus of information on which these can be trained. They're not a one-to-one correlation with what we do.
Yeah.
You also talked about consulting as another example, and you had talked about how the results were better, 40% said higher quality, but there's no indication there what constitutes higher quality, who
Yeah.
defines that,
Yeah.
what qualifies as that. So I'm struggling here because in the beginning, you talked about 95% of the web is inaccessible and it's getting more complex by nearly 12% every year.
Yep.
So the corpus of data is not only crap,
Mhm.
but arguably getting worse.
Yep.
And I think the calculator example is probably a way to simplify it.
Mhm.
Calculator is not an LLM. They don't produce the same kinds of output.
Yeah.
They're different rule sets. So
Yeah.
I'm struggling here with your first takeaway.
Yeah.
That an expert AI is better than the average human. I don't necessarily disagree that an expert AI, an incredibly well-trained AI on a rich corpus, an LLM in particular, can produce good content, but I'm not sold on it based on the initial arguments.
Yeah.
So I'm not trying to be a jerk. I just want to contextualize where my head is at.
Yep.
You're comparing two dramatically different things from my experience.
Yeah, it's totally fair. And I think what's interesting is I would say qualitative outputs versus quantitative outputs,
Yeah.
right? Like calculators and honestly, WCAG in a lot of ways are pretty quantitative. Like there is a right or a wrong answer. Like either your image has alt text or it doesn't. Either the heading order is correct or it's not. Either the form is
There, and I'm sorry to interrupt your
Yeah.
thought, but
Yeah.
I have it on my.
No, go ahead.
Even within which there are binaries for only a handful of success criteria.
Correct.
So many of the success criteria are a function of context.
Yep.
And that's why automation can only run at about 30% of it.
Yep.
With existing rules. And I don't
Yeah.
want to say separate from LLMs and the potential you're talking about.
Yeah.
So I'm very cautious about saying that it really is a binary, because missing an alt attribute, easy fail.
Yeah, totally. But getting the right one. Yeah.
That's a different thing.
Yeah, I guess where I'm going with this is there's quantitative results and qualitative results. And at least within WCAG, there's both. And actually, I'd say within any industry, there's both. And even within the SAT, like you're just bubbling in one of four predetermined choices, right? So of course, it's going to be a little bit easier. And so I think where AI is good for, or it's easy to evaluate, is in the quantitative. Like it's easy to say, when I put in 2 + 2, did it spit out 4? Or if I asked it, how many US states start with the letter W, it can give me the right answer,
You're
right?
talking about an LLM in that sense?
Yeah, like it's easy to evaluate. Like LM evaluation is easy in those contexts.
We'll say how many R's are in the word strawberry.
Exactly, and it gets it wrong. Yeah, yeah, and so I'm not saying it's always going to be correct, but it's easy to evaluate the correctness.
I'm sorry, taking a bunch of your.
No, this is, well, this is good because also the next couple slides are also going to tackle into this. But then the second thing that's interesting, that's fine. That, this would, I mean, this would be a more interesting talk too, in my opinion. But, you know, we'll get to that in the quick Q&A. But then for the qualitative questions, you bring up a good point of like, how do you evaluate the qualitative outputs of LLMs, right? And I don't have an answer to that right now. There's a lot of companies that are trying to build like LLM evaluations because people are using these tools all the time. And if you just trust the output for what it is, you're not using it in the right way, right? Like that's the whole like Centaur approach is I'll just take the output as at face value. And that's, I think, the wrong way to do it. There has to be some sort of deeper thought put into it or evaluation or something to make it a better output. So yeah, I mean, I don't think that's a satisfactory answer, but I think just I'm also working through this at the same time. I guess I didn't say this at the top. I sometimes say this at the top of the talk. Like you'll notice LLMs have no README guide. Like no one really knows what this technology can do, and we're all discovering it at the same time. So people often say like large language models are an emergent technology, and its capabilities are emerging the more that we use it. Whereas things like, you know, me playing my Nintendo 64, it's very defined. Like I'm not going to discover new behavior from the technology by using it. And so I think we're moving into a world where a lot of technology is being shipped first and tested later, which in some contexts isn't that important. But when the test subjects are humans, and at least in our industry, the test subjects are also people with disabilities who are traditionally marginalized at a higher rate, then we start to get into some ethical quandaries and questions of like, is it okay to use emergent technologies on an already disadvantaged group, right? And again, that's beyond the context of this talk, but is another question that like is worth thinking about. Yeah. I'll restate the question. Yeah.
Before you proceed, can you clarify what you mean by integrate AI plus human versus separate tasks?
Yeah, the question was, can I clarify what I mean by integrate AI and human versus separate tasks? And I will clarify with this next study. So this was another study that was just published 2 months ago from the same team. Obviously, now that I'm doing this company, I no longer work with these guys, but they send me their research studies, which is nice, and I read them. And this one was called the Cybernetic Teammate. And really, they were asking the question of how does AI function on a team versus how does AI function when I'm using it as an individual? And it'll kind of get to that question of what does it mean to integrate AI into a team? So here's this experiment. They took 776 Procter & Gamble professionals, and they were split evenly between what they called commercial experts and R&D experts. So the commercial experts all had 10 years or more of time in the commercial, and the R&D experts, I guess it was on average, not 10 years or more, but had 10 years on average of R&D experience. They gave them 1 day to design a real product. So they said, you know, go from idea generation to packaging to retail strategy and present it to our final research group. And they gave the group randomized GPT-4/4 access, right? So they put them into small teams. Some teams got these models off the shelf. Some teams didn't get access to the models. Right? So you can see it's very similar structure to the BCG setup. In this case, the biggest difference is it was a 1-day sprint versus answer these 18 questions over the course of 2 hours. So the results that we saw here was, and I'll talk through this graphic because it's a little bit complex, but there's 2 images that you see on the screen. The left image shows an individual who was using no AI answering these questions. And within those groups of individuals, there's 2 types of individuals. There's the commercial experts and there's the R&D experts. And this is a graph looking at how technical was their solution, right? So it makes sense if you look at the graph that the commercial experts had on average a less technical solution than the R&D experts, where their expertise is in technology, right? On the right side of the graph, you see individuals with AI, both commercial and R&D. And you'll notice that the graphs are almost exactly matched, but pushed to the right, meaning that both the solutions of the commercial teams and the R&D teams were more technical, right? So that's what the graph is showing. What does this mean? What I take this to mean is that by using AI, those who are not an expert in a field can at least get close to expert level results. Whether they understand the results, whether they've been trained to understand the results is a different question, but at least on pure output when evaluated qualitatively, it seems like they're getting better results, right? There's also other stuff here, like the AI teams were 16% faster. They had 37% higher quality when evaluated by evaluators. But this is a really interesting result because I bring up this point that it turns laymen's into experts, right? That's one of the interesting results. Another, and again, I put this context slide here so we get the sense of how big it is. Another result that was interesting is when we looked at individuals with no AI, teams with no AI, individuals with AI, and teams with AI, we tried to measure their emotional happiness. And what we saw is that for the individuals with no AI, they were the baseline. For the teams, so just working in a team, they tended to be a little bit happier by 0.2 standard deviations. For individuals who used AI when they evaluated their experience working on this project, they were happier than the individual with no AI by about 0.4 standard deviations. And the team that used AI was happier than all other groups by an average of 0.6 standard deviations from the baseline. And this was a really surprising study, or a surprising finding, because there was this question of how do you feel when AI is your teammate? Do you feel happier, or do you feel about the same? And this seems to imply that using AI in your work process leads to a happier team or a happier individual. Then they did the flip side, like, okay, well, does it make you less negative? And so they took the baseline, which is the individual with no AI. And again, this is all subjective, like we just said, like on a scale of 1 to 10, how happy do you feel about this project based off your output, et cetera, et cetera. The individual with no AI was the baseline. Team with no AI had a slight decrease in negative emotions because you're working on a team and it's fun and et cetera. The individual with AI had an even larger decrease in negative emotions, and the largest decrease was within team with AI, right? And so what this seems to imply is that these AI tools aren't just like a calculator, that for some reason when we're using these tools, we have an emotional reaction, especially when we're using these tools as part of a team, right? And so some of the interesting studies or results from this, and I just copied this directly from the study, is that to successfully use AI, organizations need to change their analogies. Our findings suggest that AI sometimes functions more like a teammate than a tool. While not human, it replicates core benefits of teamwork, improves performance, expertise sharing, and positive emotional experiences. This teammate perspective should make organizations think differently about AI. It suggests a need to reconsider team structures, training programs, and even traditional boundaries between specialties. This is a really new study. Again, it's only 2 months old, but it's kind of an interesting case, which is like if we want to bring in AI to our work, we should acknowledge that it will probably change the way that we think about work and the way that we think about working with others, and potentially even the way we think about working with ourselves, right? And that was one of, I think, just an interesting finding. I don't have any big takeaway from how this applies to accessibility, but I just thought it was an interesting finding that like these tools are affecting us in ways that a calculator wouldn't, or that a steam engine hasn't. So really, there's really just one takeaway here, is that using AI in a proper way is to use AI as your new teammate, right? And it's a teammate that maybe costs at the high end $100 a month, but can give you improved performance, can give you expertise sharing, and can give you positive emotional experiences. There's a lot of caveats here, right? One caveat is, like you don't want to assume that you're going to become better just by using AI. Like you still have to validate the results. And I think, I see a lot of, I teach a lot of high school students about entrepreneurship, and I give them access to AI tools, and I just ask them to share your chat history. And sometimes they'll just copy and paste the answer. And then when they come to class, I'll be like, why is this the answer? And they'll have no idea, right? And so there's a point when you use it as a crutch so much that you start to lose all context of why the answer is the answer, to the question before about training versus understanding, versus just using results. But that's all to say that AI still has some positive benefits and effects as a teammate. So yeah, I'll pause and answer questions about this study, and then we'll dive from here directly into WCAG and AI and how it relates to this room. March 2025. The study is from 2 months ago. Yeah. And my slides are also available, so you can go into the studies and dig in and read the whole paper.
Curious how you interpret the difference in the error bars. For the positive, they seem, pretty short, but for the negative, they seem really huge.
Yeah, probably just like it's just a larger range, right? So some people reported less negative emotion loss versus some that reported a lot more, right? And so I think what's interesting is from group to group, the error bars are about equal. So that it doesn't give me any pause for that reason.
But I think on the west
Scale on the
side,
left are, it's
they're much smaller.
smaller.
Oh, these are smaller. Yeah, yeah. I think to me, again, that means probably something similar that the range of responses was in a narrow band, a more narrow band. So for instance, if we look at the team with AI, even, on average, the person who said that they had a less positive emotion gain still had more than the individual who said they had a higher positive emotion gain.
Right, I understand
Yeah.
that. My question is more why it's different for positive and negative.
I'm not quite sure, to be honest. I'm not sure why it's different. But it does seem to follow that like different questions will lead to different results with different error boundings. Yeah. But again, I welcome you to just dive into the study and take a look and see what's in there. This is like a 4-slide boiled down version of like a 30-page paper.
How do we get access to the study? Is it, do we get access to these slides?
Yeah, you have access to the slides. Or if you go to, on the first slide, I had a bit.ly link, which I'll reshare at the end of the presentation, and you can just click into the source. Yeah.
Study, and I know you're following it down, did the study indicate why the participants reported being happier, like uploaded responsibility or something?
They had some guesses as to why. I don't know if I agree with their reasoning. And I know the research team, right? So everyone's just guessing. Like they have the data, then they're like, and we think it's because of this. And I always, when I see the we think it's because of XYZ, I always kind of discount it because no one really knows why, honestly. Yeah. Yeah. Any questions from Zoom? I just see someone saying thank you. So I'm assuming this is a great presentation. Okay. Yeah. Sarah. Yeah, we'll get the mic over here.
I think having a new teammate to rely on is like really great when you have like tedious, repetitive tasks that you can kind of hand off to. But with some limitations of AI, do you get the blame if your teammate makes mistakes or limitations?
This is a funny question. The question is, if you use AI, do you get the blame when your teammate has bad results?
Because when our teams want to use AI, the question always is like, because you're using AI, if it has like legal risk involved with the limitations, like is the internal team to be blamed on the consequences for using that tool?
Yeah, I mean, and yes, and for context, like Sarah's at JP Morgan, so like think about this a lot in the context of risk. The answer is yeah, like obviously whatever output you have, it's up to you. Like you can't say, no, we had a hack because ChatGPT wrote it wrong. Like that might be true, but that's not really satisfying to anyone, right? You can't take AI to court. You can only take individuals who use AI to court. And so I think that's all the more reason why it is your teammate, but you still have to evaluate the output and the result. One way that we think about this in our company is we have a lot of rewriting software that can like rewrite a code base, but it's always tied to an individual. So anytime you want to push up a pull request or push up a change, it's tied to that individual's GitHub. So like it's kind of on that person, which I think makes people double check or triple check before they put their name and stamp of approval to something. Yeah. Cool. So the new experiment is really, in our eyes, WCAG and where can we apply AI? And like I said, this is emergent technology. And so we come at our work with a deep sense of play. That's why our company is called Test Party, because we try to bring a sense of like levity and fun and excitement to these tools, because there is a lot of doom and gloom that can be applied. I'll also say generally our philosophy on AI is that there's artificial general intelligence, which is what a lot of these large language models are chasing when you give it really broad data sets. And separate from that is artificial specific intelligence, right? Which is, can you train a model to be really good at specific tasks? And let's say, across 78 WCAG criteria, can you train a model to be really, really good at one of those criteria, right? And furthermore, let's suppose it's like, form input labels, which I think is like 4.1.3 or something. Like, can we take that AI model and use it as a director of other AI tools? And so maybe you have like 15 different agents or models that are all trying to solve this one criteria or problem, right? And so there may be 78 criteria, but we may have somewhere like hundreds or thousands of agents talking to each other and doing individual tasks and being evaluated by each other to give a result that a human then evaluates. So all of that whole tree of things I call artificial specific intelligence, at least as we apply it to our work. So here's some practical examples of what this looks like in accessibility from what I've seen so far. So again, we mentioned this, it's an emergent approach. This is from Mike Buckley from Be My Eyes. He writes, OpenAI made the business decision to allow Be My Eyes, a company all about accessibility, to be the only company that had access to visual description models. People who are blind or have low vision were directly involved in the development and honing and improving of the product. And so in this case, this emergent approach has some positive effects, right? Because no one knows that this technology will be used. Let's specifically use it, have blind and low vision people use it and give feedback so that as this emergent technology is developing, it can be refined to be the most helpful for everyone, right? And I think, again, all of AI technologies today follow this kind of same emergent approach. So let's talk through automation WCAG. I'll give some specific examples here, and I'll focus again just on remediation, not testing. Like there's a lot of other companies doing testing, and it's a pretty saturated industry. AxeCore is really great. Events has some good tools there. Testing is definitely interesting, and there's a lot of testing tools. I'm focusing on what I think is going to be the next level, which is remediation tools, which I'll put ourselves in that bucket. I'll put GitHub Copilot, Replit, Codium, SonarQube, Snyk, Vanta, Drata. These are all companies that do very similar work to us, but in different industries. I'll especially highlight SonarQube and Snyk. These are two security companies that are focusing on security automation, right? And so just like accessibility, like there is a way to be a more secure organization, but there is no way to be 100% secure. And yet there are still companies that are selling technologies and tooling that can scan your code base, that can look at your public website, that can spin up AI agents that will run tests and give you results. And beyond that, these two companies, SonarQube and Snyk, are also trying to solve that automatically, right? So when I think of what could accessibility become, these are two companies I look towards as really good case studies and examples of building in a qualitative process into a quantitative system, right? Building in this kind of how do you assess security with data and metrics. And that's what these two companies do really well. Vanta and Drata do something similar for like SOC 2 compliance, if you're familiar with that. And we are a Vanta customer. And so it's actually kind of fun to be on the other side of the auditing process when it's security auditing and to see how things are different and the same as accessibility auditing. So let's get to this question of how much WCAG AI can remediate. I was lazy and working as a cyborg, so I just asked my AI the question, and it gave me some answers. So first I asked DeepSeek, and it said 70% automation. This was in March of 2025. It said it believed that 20% could be fully automated, and 50% would have to have human in the loop. Human in the loop is defined as when AI spits out a result, the human has to approve or reject it, or tweak the result before they actually implement it. So that was DeepSeek's answer. Claude said 75% automation, 16% fully automated, and 60 to 65% with human in the loop. And I linked all my chat transcripts here. ChatGPT said 80% automation, 50% fully automated, 30% human in the loop. Gemini said 95% automation. I think it originally said 100%. And I said, are you sure? And it said, yeah, 95. Okay. 50%, 56% fully automated, 39% with human in the loop. I saw a hand in the back for a question, yeah.
Those percentages for automation, is that with accuracy? Like, did it test for accuracy of the results?
I just asked it the question. I didn't give it specific examples. Like, I think the right way to have done this would have been to build a test website where you know the issues, then to feed it into the AI and have it spit back the results, and to see out of the 78 issues for WCAG that you found, how many it could fix. That wasn't the approach that I took. I just asked it. But that would be the right approach to take.
I have a question. I went through your slides to look at some of the chat question responses.
Yeah.
A lot of the links don't work, but the Claude one works.
Okay.
And it mentions in its list of fully testable and remediable criteria, some that are just kind of known to not be automatable. So
Yeah.
what is your response? Like, it has on focus, can't detect context change. You can't really get that with a linter because you need the actual DOM and you need events and things that are happening in real time while the screen reader is interacting.
Mhm.
3 flashes, you also can't get that with a linter if you're importing a third-party package that's creating 3 flashes.
Mhm.
That wouldn't be the code
Mhm.
necessarily.
Mhm.
So I guess what is your response to there being kind of this misunderstanding? If you ask the AI what it can do about something that it doesn't fully have the context of, like Adrian talked about,
Mhm.
purpose not being there, it's gonna produce an output that's not fully accurate.
Yeah. Well, I guess I'll question the assumption, right? The question for people on Zoom was, it seems like when you look in the Claude response and you look at the prompt, some of the answers of what it said it could automate didn't make much sense because you actually can't automate it when you just have code-based access. And so one of the prompts that I gave it, I don't know if it's in there, but it probably should be, is assume you have full access to the code base, full access to the DOM, and you can run computer vision on the rendered page. And once you give it more components, you can actually start to get some of this stuff, right? Because if I have a rendered page and I can screen record for 10 seconds, I can see if there's 3 flashes. And then I can compare it to the code base where I know the 3 flashes are occurring and I can see if there's this discrepancy,
Sure.
right?
But
This is,
that's, you're saying like, this is a hypothetical. Is that kind of technology for running an AI agent on the machine using, machine vision to do the 3 flashes is not there yet?
I mean, that's what we're building, right?
Okay.
So that's the company, essentially. So it doesn't exist yet, exactly. And that's why, like, when we prompt it, we say, hey, assuming you had DOM access, assuming you had a remote machine that could print out every screen reader element on this page, assuming you navigate via keyboard and you can watch the focus ring move on the page, what would you do with that information and how do we use that to change, right? And so, yeah, I think, and that's why I say, like, traditional testing is really just, let me scan the code base. Like, let me look at the rendered page. And there's no relationship between that static analysis and that dynamic analysis. And once you draw that relationship, you can start to create a lot more insights, right? And so some of these rules that seemed like impossible to fix, like I would take it, I don't think they are. Not everything can be fixed, but some of these harder ones can definitely be fixed. Yeah, I guess you dug into the secret of the company. That's our Coca-Cola secret sauce. Don't spread it around, guys. Yeah, good question. And you're getting into this next thing is about what can't AI remediate. And if you go into the appendix of the slides, I just copied some of the ChatGPT responses and have specifically what ChatGPT acknowledged it can't remediate. But I did try to also pull in some of the responses, and so I asked the AI, what can't it remediate, and it gave me this grid. I won't dive into everything, but on the x-axis they have subjectivity and context dependence, which is the same question we just asked about. I think Adrian asked this earlier. Then we have automation feasibility, high and low, right? And so it used this to try to put a matrix, right? So if it's highly subjective and there's low automation feasibility, then maybe it's not super automatable. I asked Claude the same question. It gave me technical complexity versus contextual judgment. So again, you see this kind of context versus difficulty matrix. We asked Gemini. It said basic pattern matching versus advanced AI. So again, automation from AI versus simple or rule-based or contextual and complex. So again, you start to see like how these tools tend to think about how to split up the WCAG criteria into what can be automated and what can't be automated. But I do want to take a step back. I'm not saying AI is like the panacea silver bullet that like all is lost and accessibility has no place. I think that AI can't replace what all of us in this room and all of us on Zoom do when we're at our best. Right? And that's where I come back to this equation that I talked about like now 45 minutes ago, which is that there is us, this Victor Stone, there are these tools, but it also requires our judgment, right? Like we are the humans that are building technology for humans, and someone has to be held responsible and accountable for the results. And that's where it requires heart, like our own effort and our own desire to build great technology in order to really have a positive impact versus just putting things out in the world that we think are going to be okay. And so that's why this is a critical part of the what I call accessibility superhero equation. Like you have to have that sense of heart, looking back, ensuring that what you're doing is right and good, and that the results are also right and good. And so this is really something that I just want to add as a caveat that like AI can't replace what you do at your best, which is being this empathetically human person. Like even if you don't have a disability or you don't have the disability of the person that you're trying to help, you have to empathize enough to do that design thinking and to do that deep work so that you can operate at your best for that person when they're not in the room all the time, right? And I think this is table stakes, but I just wanted to say it because it's super important to acknowledge the difference between AI as a tool, AI as a teammate, and how we as humans then use this to make impact. This is a marketing slide. So let's talk about some specific WCAG remediation examples. We talked about human in the loop, and all of the examples I'll give focus on scanning source code, like in the scale of like hundreds of thousands of lines of code, finding issues based on WCAG, again, comparing the source code to the DOM, the rendered page, and then having the human approve or reject the changes in context. This is something that we do every day, like spell check is an example of human in the loop coding. Fraud alerts, like if you try to buy like a $17 smoothie and it's like, this seems like fraud, you don't like smoothies. Yes, I do, right? That's a human in the loop check. Autocomplete is human in the loop, right? And so I'm saying this because we're trying to apply human in the loop to accessibility. And I think even DQ is doing this as well. I listened to their talk a few months ago, and this is some examples of what human in the loop looks like. Probably the funniest example of human in the loop is reCAPTCHA, right? When you go to a website and it's like, are you a human? And it's a robot asking you if you're human. I just always chuckle at that human in the loop example. It just makes me really funny. And so we'll start with the neurodiversity rule set. This is one that we've built ourselves that we think is really AI first. Like you couldn't really create this sort of stuff without AI tooling. And it's really the 3.1.x rule set. Language of page, parts, unusual words, abbreviations, reading level, pronunciation. These are things that AI is really well primed to do, especially if you give it the context of the page and just the context of the organization specifically. So there's a lot on this slide, but I'll try to break it down really simply. What we do when we test our tools, we take the before, which is like all of this text. In this case, it says this text is mostly English, pero esta parte está en español, but the rest is still in English, right? And so it goes from English to Spanish, back to English. And then it's another paragraph tag that says this part is working well, no remediation is needed, right? And so in theory, a tool should be able to scan through this to figure out where there's a different language, to put in a span tag for that language, and then to spit back the result for you as a human to accept or reject. And so this is one example. I'm just giving examples of where we can use AI in the accessibility space that we think is pretty well primed for this sort of change. Yeah, as you can see, we can do this. It's something that we did back in like February or January of this year. Similar things are like unusual words, right? So in this case, we have the paragraph or the sentence, he obfuscated it, now I can't see it, and his walk through a verdant garden surprised the visitors, and this text is working well, no remediations needed. You could argue that the word remediations is pretty complex, but that's neither here nor there. So that's the before. Again, we take this, throw it into some code base that we know is functioning fine, and try to see if our scanner and AI tools can pick it up. And again, this is just examples of what AI can be doing. Again, in this case, he obfuscated. We can insert a definition. Whether or not you think this is the right way to remediate it is a different context from whether or not it's possible. You know, his walk through the verdant, and we give a definition of verdant, green with grass or other rich vegetation, and then the human can approve or reject or modify it as needed. I think pretty deeply that this is where most all tools in the developer tooling space are going. Like Codium and Cursor are two of the largest, I guess it's called Windsurf now. Windsurf and Cursor are two of the largest code writing tools, and they take this approach of you prompt it, you get a bunch of code back, and you choose what you want to keep or reject. And like SNCC and SonarQube, the security tools are also doing this as well. Right? I think it's only a matter of time before it starts to apply to every industry. And we look back in say 5 or 10 years and think, well, of course, like we'll have the AI give us the first pass that we'll then tweak based off our human judgment. We have another example here about abbreviations. These are all just the 3.1.x rules, which again, before AI, were not easy to solve or to fix without huge databases where you index maybe, in this case, FBI to FBI and FMI to FMI. In this case, you can type in any abbreviation, and when you take the context of the page, it should be able to spit out the right abbreviation. In this case, the solution here is to add an abbreviation tag around FBI or around FMI, right? And again, to be able to run this within a 100,000 line code base and find these minor issues is a sort of solution that we're thinking of will be implemented either by us or by someone else. And really, it's just a question of who does it in a way that's really easy to use and intuitive and honest. Second example that we have is all around alt text generation at scale. So one of our customers is a company called Arena Club. They do trading cards, started by Derek Jeter, who I think is a baseball player. I don't really follow sports. I think he played baseball. Is he still playing? I don't know. Yeah, I don't know anything about him. I just know that he has a trading card startup, which is kind of interesting. They produce 4.5 million images a year, and they're a growing startup, so that grows. And these images are, if you had a trading card, you can like take a picture of it, they will verify it, and then it's almost like eBay for trading cards, with even more verification. And so they're starting within this trading card space, and they're going to Pokemon cards and other collectibles and all this sort of stuff. How would you remediate 4.5 million images a year manually, right? Like, especially if it's user generated, potentially you could have the user put in the right answer, but the user might be wrong, right? You don't want to just trust the user. Okay, maybe we have a team that checks it. Like, how many full-time people would it take to check 4.5 million images a year? And plus, how fulfilling would that job be, right? Like, do you like 9 to 5, like alt text all day? You know, like it's just not super fulfilling. Like, I think as accessibility professionals, we want to be working on higher level thinking. Like, is this the right flow for a user who's visually impaired to be able to check out versus does card number 3 million have alt text, right? So this is an interesting example that we came across. Drew Dries, I don't even know how to pronounce his name, but the founder of Drupal did an interesting study because he also was thinking through this, because Drupal is this massive open source platform used a lot in the education space, and he essentially published this paper around how good are models at generating alt text. And so he took models like Cloud 3.5 Sonnet and Llama and GIT, and the core finding from this slide is that not every model is created equal. Like, some are better at creating alt text than other ones, for the alt text example specifically. And you can extrapolate this to say that some models are just better at certain tasks than others. And I think in this study, what he did, you call it a study, but really it was just him on a weekend. But what he did is he essentially took an image, put it in this model, got the alt text, and tried to see how often was it hallucinating, how often was it repeating, and how would he score it on a scale of bad to good. Again, I linked it here, so you can just go directly into his blog post and take a look at it. But you'll notice all these different studies have different results, right? So this is just to say that not every model is equal. And so the way that we try to mitigate this, and the way that I would suggest you mitigate it in your own organization, is what we call AI agent evaluation in the loop, right? And so we talked about human in the loop, where I'm approving or rejecting a change. Essentially, AI agent in the loop is very similar, but rather than me, the human, saying this looks good, it's an AI agent saying this looks good, right? So a really practical example of how we do this with Arena Club is we'll have, say, a Claude develop the image alt text, and then we'll have a ChatGPT look at the image and the alt text and say, how accurate is this, right? And then we can have another, maybe even a DeepSeek. We don't really use DeepSeek, but in theory you could. And we'll have that DeepSeek set with the prompt that says, you are an expert alt text evaluator. Here's what you look for when you evaluate. These are the 20 different criteria. Like, now evaluate the alt text that Claude said was good and see if it really is good. And then you spit it back to a final human to say, yes, this looks good, or no, this doesn't look good, right? And so now what you're doing is you're stacking these agents on top of each other so that the false positive rate decreases. And this is just for the case of alt text. Like, you can imagine how this applies throughout the rest of WCAG. But that's one thing that we're thinking through a lot, right? And in this case, the secret sauce, like what makes it really effective, is the prompts that you're using. And how are you fine-tuning, and how are you evaluating your models? So that before it gets to the human, when the AI agent is in the loop, you're doing great evaluations. Then the job of the 9 to 5 really is just clicking approve or reject. Or if you're the human or the user uploading, you're just clicking approve or reject. And it's already been vetted by something or someone before it gets to that human. So yeah, that's everything about the alt text. Third example, and then I'll pause for questions, is what we call PDF to HTML generation. And this is actually more, like when I mentioned at the top of this that there's different types of AI, I've been talking almost entirely about large language models and these prompting systems. In our PDF tool, we're using more computer vision. So what we do here is we take pictures of PDFs, we turn these PDFs into web pages that look visually the same, and in that transformation, we add tags, heading tags, image alt text tags. We try to preserve heading order, all this sort of stuff. And it's a different type of a way of applying AI, but still has some accessible outputs. So I think the best example of this was with Pepperdine. They had a blind student who needed to get their coursework for the semester. Usually they would pay $3, $5 a page to do this. It would cost $10,000 to $20,000 on the accessibility department's budget in order to do this. They were able to use Test Party as an open source tool where the student just uploads their PDF and gets back the HTML page. Not every PDF can be addressed this way. Like we've worked with governments where they have really complex, like kind of agenda packets that have like engineering and CAD documents. Those, quite transparently, we haven't figured out how to solve. And so like there's still certain areas where like a human needs to come in and do the heavy lifting. But when you're a resource constrained, budget constrained, public or private university, these tools can help you get to a good enough status for enough documents that you preserve budget for other needs or for other cases. We always try to tie every one of our customer goals to like a broader industry goal. And at least with Pepperdine, that industry goal is, can we increase the graduation rate for blind or low vision students, right? Because I think right now the graduation rate is about 42% versus the US graduation rate of 62%. And our hypothesis is that's because people just don't have access to schoolwork. Like, how are you going to graduate if you can't actually read the documentation, right? There's a question in the chat if it works for forms, and we have built out a prototype for forms that does like Google Forms. So it takes the PDF, transforms it in the ways I was describing, and then you can hit submit, and it submits it as a Google form, since that's like open source. There's a bunch of other things that we're testing, like even what's not on here that we just started doing like 2 weeks ago is like a lot of like screen reader testing. So can you like read out a screen reader, get the transcript, compare it visually to a web page, and see where there's gaps or if there's things that don't make sense, right? Like that's something that we're playing around with quite a bit as well. I'll pause here. What questions do people have on the 3 examples I gave?
Sorry, you mentioned open source. I missed what parts of that was open source. Could you describe more about the open source part of the previous slides?
Yeah. I mean, technically all of this, you can implement yourself.
Sorry, what's that?
All of this you can implement yourself,
Okay.
right? So like in this case, the language of parts, like we are just using off-the-shelf models that we fine-tuned to these specific use cases, right? And so the open source nature is that like, yeah, you could copy your whole code base or copy parts of your code base, put it in the ChatGPT and try to get a result. Like the difficult problem here is building the infrastructure for this to work securely in a way that's at enterprise scale. Yeah. And so really all these examples I showed, even the alt text example, right? You could upload, you could use maybe a Zapier, for instance, to like create a flow. You could upload an image, put it to ChatGPT, have another flow that checks the image. Like that sort of stuff is not the hard problem to solve here. Yeah. Yeah.
That's one. Who the human in the loop should be if, for example, our firm were to leverage AI in that approach, because a lot of our devs really don't know about accessibility and are like just starting and would likely be centaurs. So do you think we should have like our subject matter experts, like those who do QA, to kind of train and kind of fine tune with the prompts first before we widely distribute more across our engineers so that they could kind of start to learn about it after that's been set?
Yeah. The question was who should be the human in the loop? And it doesn't have to be just one, right? And so obviously like the more checks that you have before you ship something, the better it'll be, right? Like the whole purpose of QA is to be the human in the loop for human created products, right? And the first human in the loop is the person making the product. And so we're just adding more checks. And so I think in theory, like maybe you have the person building the application, right? You have your central accessibility team who like checks all the products and checks for regressions. Maybe you have a QA focused team or engineer. It just depends on like organizational sophistication. I don't think that's a satisfying answer.
I'm just curious because there's also teams who don't have those support, like subject matter experts just yet.
Yeah.
And it feels like they can't access this kind of approach just yet.
Yeah, I think what you're kind of alluding to is like how do you give training to people so that if they're the human in the loop, they have the right context to know if it's the right or the wrong fix. And so there is another concept of like if I go back to this slide, um, what you notice at the very top of this right-hand side below where we put the actual stack trace of the issue is a short description of how you would solve it, right? And in theory, this description you can make as beefy or as not beefy as you want, or you can link it out to other websites. And so there is also something to be said about training in context, right? Like it's almost like right as my tire gets flat, I'm teaching you how to change a flat tire versus giving all the information at a time when you might not use it. So I think training is obviously the easy answer, but the hard answer is like how do you know who to train? How do you give them the right training? How do you know if the training is being effective? Like in theory, you could maybe do some data analysis on this sort of stuff to see if it's working.
So elaborating a bit on human in the loop, and we talked a lot about, or some about qualitative versus quantitative. So we're thinking about like qualitative responses inside the context of like a large enterprise organization that may have their own standards or additional standards to like WCAG, and thinking about feeding results back. When I'm speaking to a human, I'm speaking to my development team, I can go back to them. I can say, hey, we're seeing this type of pattern, this type of issue, let's remediate that. When you get the AI, kind of generating those, can you talk a little bit about the test party's approach to maybe customization or enhancement or feedback loop into that AI, and how does that work within an organization where I can't just go back to the AI and say, hey, that answer you gave me 2 weeks ago ain't right.
Yeah.
You all approach that.
I mean, you could say that, right? We just flag it as a false positive.
So you can go right back into, you have a list of like the history of questions, and you
Yeah,
can go back into that history and say, directly without having to retrain the RAG or whatever, you could just go right and say, I do not want you to give this response anymore. My organization's intent is X instead of Y.
Yeah, I mean, some of this is product features, so it's good that Jason is here taking notes. Because like obviously that's why we do these talks to try to understand like where we have gaps. But yeah, that's definitely a growth area. But we do allow you to flag for false positives. We do allow you to create custom rule sets. We do allow you to toggle things on and off. Like obviously under the hood, a lot of this is X.
Yeah.
A lot of this is also open source rule sets and our own things that we're building, right? And so like if you need to customize a rule set, build your own rule set, like that's not impossible.
So you mentioned before that you're using off-the-shelf models and software. I'm curious about the hardware. So how cheap can the hardware be and still run this kind of stuff? Can consumer grade hardware do this?
Yeah, like I can open it up on my laptop and run it on my personal
Without
computer.
network access?
Yeah, like no internet connection, you mean?
Right.
Yeah, if the LLM is downloaded locally, yeah, of course. Yeah. Yeah, like if you have like a llama, which is like more open source, you can download it, has all the weights already, then you just have all of our AI calls that would maybe go to a Claude or a ChatGPT just go through llama instead. What you lose is some of the agent to agent communication, which is how you can lower the false positive rate. But what you gain is it's all off the cloud, essentially.
Just a 5-minute warning.
Cool.
Are you able to show either a screenshot or the process of PDF to HTML? What does it look like when you take a picture of the PDF and tag it?
Yeah, I can show that. They're the last 4 minutes that we have. Maybe I'll just send you an email afterwards. I'll just shoot you a video to the demo. Yeah, that'll be the best thing. Cool. One more question, and then we'll move on to the last couple slides here. I don't think any of us are. Yeah, no one. Yeah.
Standards is getting the content up to meeting the standards, and I work at a university where there's a lot of old faculty, they do things the old fashioned way, aka they scan a chapter of a textbook into a PDF and they say it's accessible, and I'm like, no, it's not, homie. It's not. Are there AI tools that can assist with those kinds of things?
Yeah, I mean, I think you'd be surprised if you just took that scanned textbook and you uploaded to ChatGPT and you said, extract the text from this image. It would spit back out the text. Right. And so like that's like definitely like level 0 of like, okay, like a professor just scanned 30 pages of a textbook. Like, what do we do with this? And that's It's called OCR, like character recognition, and it's like these open source tools are able to do that at really high accuracy rates. Um, yeah. Yeah. Yeah, I mean, it's definitely getting better. Obviously, check every output that you get, and like obviously, like it may not get the images correct, right? But like just pure text to text scanned images, like it's pretty solid. Yeah, I upload pictures all the time and just ask it questions to the pictures. Or like I'll take screenshots of a document and I kind of want to upload the document, and I'm able to query it, no problem. Yeah, yeah. So in the last couple minutes, I think we have 2 minutes left. I'll just talk about why this matters, and why the work that you do still matters. I think we can all recognize that compliance is the floor, right? So like we're saying that we want to automate WCAG compliance. I'm not claiming that we're going to make everything accessible to every single person in the whole world. Like compliance is the floor, and the question is how can we get more people to be at the floor? Obviously, the work that you do matters. Like everyone in this room, everyone on Zoom. Like the reason why we chose to be in accessibility is because we feel a sense of meaningfulness from the work that we do. And even with AI tools or an AI teammate, the meaning that we create and generate still matters and still has an impact. And obviously, like the goal of all of this is that we want to do more human work so that every human can experience technology in a better way, in an equal way, whether it's technology or course content or whatever it is. The goal really ultimately goes back to Victor Stone. Like the goal is when we're giving our 110%, we want to get more than 5%. Like we want to get 110%, right? We want to be able to build and improve faster than the rate at which the internet is growing. And so my hope is that you all play around with the AI tools, right? It's emergent. We play around with it all the time, every day. Sometimes it works, sometimes it doesn't work, but the only way to know is to play around with it. But do it responsibly, right? Like you don't want to just like scan something and say, you know, AI suggested I rewrite it like this, I'm going to rewrite it like this, right? Like you'd be surprised. I think the number one AI code generator right now is probably like Codium, or Windsurf or Cursor. They're generating $1 billion lines of code every month, and I can guarantee those billion lines of code are not accessible, right? And so if you just take the approach of like, let me use the 97% of the internet that's not accessible and use it as training data, you're going to have inaccessible outputs. So play around with it, but play around responsibly. Yeah, this is really the thesis that if you automate WCAG remediation, you can hopefully use AI tools as assistive technology that makes you do more. And yeah, you can become a bit more like Victor Stone, where it's you plus these AI tools plus your heart to become some sort of accessibility superhero. So thanks, everyone.